Okay, hello students. In this video, I want to show the relationship between, this is lesson number 3.1, and basically this is about the function of a quadratic function in the vertex form, x minus h the whole square. That's the vertex form, and this one, when you write the same one, written ax square plus bx plus c. This is the standard form. So the question is, what is the relation between these two, and how can we compare? So this case, the vertex is h and k. So how did we get this vertex hk? And you can see, I can take see any example. Simple example, I can say, let's say a is 1, so 1, and then minus 2 and plus 3. What does this basically means? Is that means if I draw x-axis and y-axis, the square function that you have, that is x square, the original function, which is, let's see, this is the square function. This square function, suppose this is the square function, okay, which is a parabola, opens up, concave up, or opens upward. This one, this moves two places to the right, so that we go 1 and 2, and then you go 1, 2, and 3. So the whole parabola is this way. See, so this is the parabola, and that's the vertex, which is a turning point, and that's h comma k. So the h is 2 and k is 3. So that this one, the h which is right here, that means h is positive, so shift to the right, and k is positive 3, so it shifts up. Now I want to write this whole thing in the form of this part, and then I'm going to show how to go backwards. So, okay. So if you see this, we can, I want to write this. How do I write it in the standard form? Let's use this. I'm going to change this. I try to use a scalar factor by 2 here. So it's like 2, this 2, which is there, this 2 is plus 2, and it is greater than 0. So it's stretches vertically upwards. So vertically uh, upward. So stretches vertically. Now I want to use what is x minus 2 square. So that will be x square minus 4x plus 4, the whole square, plus 3. And then that will be, so there's no 2 here, sorry. And then you use the distributive property. So this becomes 2x squared, then minus 4x and plus 8 and plus 3. And then you end up getting 2x squared minus 4x plus 11, and there you go, and you get the answer. So this is a is 2 and b is minus 4 and c is 11. So that's how this a b c is related. Our question is, uh, if suppose you're given another function, and this time let me take one function which, uh, let me take let me clean this off. So let me take a function. If gx is minus 2x squared and plus 4x and minus 5. So how do I write this in the vertex? So all you do is you take the first two terms. What do you see? Somehow you have to get x squared and plus bx. Suppose I want to write a perfect trinomial. So what goes here to become perfect trinomial, and that is nothing but you take half of b and then square, and you get b square upon 4. So that's all you get, and then you can see this becomes x plus b over 2 divided by square. So how do I get this 1x square? So basically this minus 2 should not be here. So what I'll do is I'll divide this part, both one, divide by minus 2. So there is a minus 2 and there is minus 2. And at the same time, I'm also multiplying by minus 2. So to balance it, right? So the minus 2 is outside. This minus 2 goes, we get x squared. And 1 plus and another minus would come minus 2 divides 4 2 times. So this is 2x. And then I leave us room there, space. And this 5 is outside. That stays. Now we need to add we need to add something here and also right. Now be careful whether we add that we have to look up. So what you do is uh, now the b which is right here, it is -2. So I'm going to write -2 half of this and then square, right? Because it is b over 2 square. So that becomes -1 square is 1. So this one I'm going to add +1 there. So this is +1. And outside, I can't write -1 because when you use the extra term that is already being added is -2. So this is -2 times +1, which is -2. So this becomes opposite of -2 is +2. So we have to write +2. So this end up getting -2, and this whole thing is a perfect trinomial. So I can write this as x minus 1 because this one is 1 square. So this is like a a and this is like a b. And you know that a square minus 2ab plus b square is a minus b the whole square. So I'm going to use that thing and equal this whole thing become -3. And there you go. This is in the vertex form where h becomes, so the h will be, so the h is right here, which is 1, and k is the -3. And that's it. But the question is, if without the question is, suppose can we figure out this 1 and -3? So the vertex is 1 -3. And because there's a minus, in the beginning it was minus, so there was a parabola which opens downwards. There is a maximum here, maximum points, and the maximum value of the function. The maximum value of the function is the k, h. So this is the maximum value. So my question is, without writing in the vertex form, can we use only this quadratic and get it? So that's my goal here. So what I'm going to do is showing the proof. So so let's try to verify what is the relation between, our goal is to what is h and k, how this h is related to a and b, okay, and what is this related to a and b. So if you see this is ax square, which is already in the standard form, the first thing I'll do is just to show you this one bx, okay. I'm going to write plus c very far, and let's see why it is. Now in the first two, there's a a here, so I'm going to divide by a. So let's use the color there. So divide by a, and to balance it, now this one I'm going to use parenthesis, and then here because you multiplied here, and then I'm going to use the a at the outside, so the red a. Okay, so we can cross this out. The blue one crosses out. See? So all what stays is the a which is outside. The a is outside, so it becomes x squared plus b over a, and then x, and I'm keeping that room for me. Let's see. So now we need to make the parenthesis as a perfect trinomial, and all you do is use the what is that to be added, the last term. So we need to add something here, right? So to add that, we use the half of the coefficient of the x. So the coefficient right now here is b over a. So you take half of that. So it's like half of the coefficient of x, that is this, and then you square this. So you can see it is b over 2a the whole square. So I'm going to write this is with the color to show that you're adding, so which is b square over 2 times 2 is 4, and 4 is square, so that is b upon 4a square. Now I can't just add, I have to also balance it. Now that's where is what is that to be added? This a gets multiplied here. So the extra term is, I'm going to write a step here. The distributive property, if you multiply a to b square over 4a square, So there are two A's. One of the A's crosses out. See this? So what are you left with? Only b squared over 4a. So we need to do the subtraction here, and that is b squared over 4a. Now we can write directly because the parenthesis is a perfect square. So this is x here. There's a plus sign. So put a plus sign. And remember the pink color, this thing is because of this, right? So this is b over 2a is the main one. So this is b over 2a, the whole square, and plus c minus b squared over 4a. So that means now you can compare this form to this is exactly looks similar to the the what? The quadratic to the vertex from plus k, and clearly see what is h and what is k. So the h and k that you see here is nothing but this h, this h is this opposite. Now see this is plus b over 2a. So and this is minus, right? So it has to be the opposite. So h is minus b over 2a. And the k is c minus b square over 4a. So this is the main formula of the relation. So all you do is the h case you just find out. So this when are we going to use this is basically is if the question is asked only to find what is the maximum or what is the minimum, then it's better to write here. You say okay, x equals you find out b minus 2a, and whatever that value you get, this is the output. So this is the output. So all you do is the input, this is the input. So this input you plug it in f of whatever the function minus b over 2a, and you get this output. Otherwise this is going to be very tedious to work out. So this is easy just to plug it in. Let's take one example. So I'm going to take the same example. Let's say you're given a quadratic form gx, and that is minus 2x squared and plus 4x minus 5, right? So now the question is, what is the maximum or the minimum, okay? And you know there's a minus before the coefficient of the leading term is minus 2, or the degree term is minus 2. Uh, so comparing with ax squared plus bx plus c, clearly a is minus 2, b is 4, and c is minus 5. And then the formula said the h is minus b over 2a. So what is minus means? You do the opposite of b. So if this is plus b, you just do the opposite, which is minus. And 2 times a is minus 2. There you go. And two negatives makes it positive, and 4 over 4 will be 1. So already you get h is 1. So that's the x coordinate of the vertex. And how do you find the k? So k is you are plugging in this. See, this is the formula. So it means the main one in this example, g. So you replace x. So this x, which is that 1. Now this is 1. When the input is 1, what is the output? It means f of 1, because this is 1, right? So all you do is you plug in this one, you plug in here. So that means the minus 2 will stay minus 2, then square plus 4 and minus 5, and I'll plug it in the 1. So this one, you put it right here. So that will be 1 and 1. So which will be minus 2 and plus 4 minus 5. And we'll work this out, you get minus 7. 4 minus 7 is minus 3. And that's how you can get, you see the vertex is HK, and the answer is this one and this minus 3, and you're done. So that's how I wanted to show this. The reason to show this is, let me do one more example. So I'm gonna end this video by, so so the conclusion is, what did we learn from here is that so if the function is in the vertex form plus k, then the standard form is ax squared plus bx plus c. So the relation between h and k is the vertex is this vertex, which is h and k, is minus b over 2a, and then the output is f of minus b over 2a, and you're done. That's all it is. This was the goal, whether we understand that it's really true. So I just want to make sure, why is this? What is the reason? And then I try to show the proof. So with this, I want to end this video clip, and I want to make another video clip with is how do we use this in the real life application.